Hello friend, today we are going to discuss about failure mode and effect analysis, that is FMEA. This FMEA is based on AIG manual, that's fourth edition is published in June 2008. What is FMEA? We are going to discuss in introductions and what are the application of FMEA and management supports and safety approach, FMEA terminology and concept for understandings, and what are the benefits of, for using of FMEA and design FMEA, their introduction, explanation and implementations, and linkage between DFMEA and PFMEA, and process FMEA, their introduction, explanation and implementations, and how to create FMEA, FMEA implementation guide, revision in FMEA and example of DFMEA and PFMEA, and there is also a linkage between FMEA and control plan that we are going to discuss one by one in detail. First, what is the introduction of FMEA? Means what is FMEA? Actually, FMEA is an analytical methodology that used to ensure that potential problem, anticipated problems, all the potential problem or anticipated problem has been considered and addressed throughout the product and process development processes. Means throughout product and process development, all the potential problem has been considered and addressed. And part of the evaluation and analysis is assessment of risk. Means discussion is conducted regarding the design, review of the functions and any changes in application and resulting risk of potential failure. Like each FMEA should ensure that attention is given to every component within the product or assembly, and critical and safety related component or process should be given in higher priority. Means critical and safety related components or process we need to focus as a higher priority, means they are higher priority. Now, one of the most important factor for the successful implementation of FMEA program is timeliness. Means that it should be before the event. Means we need to make the FMEA before the event action, not an after the fact exercise. Okay, we need to focus on FMEA, or we need to make an FMEA before the event. We need to take all the actions, not after the fact or exercise. To achieve greatest value, the FMEA must be before the implementation of a product or process in which the failure mode potentially exists. Upfront time spent properly completing an FMEA when product and process changes can be most easily and inexpensively implemented, which minimize the late changes, crisis, and action resulting from FMEA can reduce or eliminate the chance of implementing a change that would create an even larger concern. Ideally, the design FMEA process should be initiated in the early stage of the design and the process FMEA before tooling or manufacturing equipment is developed and purchased. Means in design FMEA, early stage of the design, when design is just going to start, we need to make design FMEA, and in case of process FMEA, before tooling or manufacturing equipment is we need to prepare process FMEA. First, what are the application of the FMEA? There are three basis cases when FMEA is to be applied. And first is new design or new technology or new process. When we are introducing new design, new technology or new processes, we need to revise our FMEA. And second is modification to existing design or process. If there is any modification in current or existing design or process, we need to revise our FMEA. Third one is use of an existing design or process is in a new environment, location, application or users profile, that including duty cycle, regulatory requirements, means government regulatory requirements, or and existing design or process in new environment or new location or new application. Any application change in application, any location change, any new environment is change, we need to modify our FMEA. Next is management support and safety approaches. Development of an FMEA is multidisciplinary activity, means that affecting the entire product realizing process. Implementation need to be well planned to be fully effective. Importance to FMEA develop is a process owner and senior management commitment. Means an FMEA is developed by a multifunctional, a cross-functional team. That is, the team size will depend both on the complexity of the design and the size and organization of the company also. And the team members need relevant expertise, available time and authority sanctions by the management. A comprehensive training program should be implemented, including management overview, trainers for user and supplier trainer and facilitator trainer. Ultimately, management has the responsibility, the ownership for their development and maintenance of the FMEA. Next, what are the FMEA scope? Actually, FMEA scope is stabilize the boundary of the FMEA, that is defined what is the included and what are the excluded. Means determine mission is based on the type of FMEA being developed. First is system FMEA, second is subsystem, or third one is component. Means what we are going to consider, that is system, subsystem or component. Like for example, we have a assembly products and we have a assembly products like engine assembly, and there is a sub assembly product, that is engine mountings, and there is a component, that is suspension bushes or their ceilings. That is the types of FMEA actually. That is the FMEA scope. Means system is engine and engine assembly, and subsystem is their engine means engine mountings assembly, and components is their bushes or their ceiling products. Now system FMEA. A system FMEA is made up of various subsystems like chassis system, powertrain system, interior system. And system FMEA is to focus, in system FMEA we need to focus to address all the interface and interaction among systems, subsystem and environmental of the customer. Subsystem FMEA, actually subsystem FMEA is a subset of a system FMEA. That is, example is front suspension subsystem assembly, which is a subset of chassis system. The focus of subsystem FMEA is to address all the interface and interaction among the subsystem component and interaction with the other subsystem or systems. Component FMEA means a component of FMEA is subset of a subsystem of FMEA. For example, a brake pad is a component of brake assembly, which is subsystem of the chassis system. Means chassis system is a system FMEA, and their brake assembly is a subsystem FMEA, and brake pad is their component. These are the examples. Next is what are the customer in FMEA? There are 4 major customers to be considered during the FMEA process. First is end user. The person or the organization that will utilize the product is end user. OEM assembly or manufacturing center plants, the OEM locations where manufacturing operations like some of the stamping products, powertrains, or which vehicle assembly take place. That are the OEM assembly or manufacturing center plants. Next is supply chain manufacturing. The supplier location where the manufacturing, fabrication, assembly or production material or parts take place. That is supply chain manufacturing. Next is regulators. Means regulators mean government agencies are regulatory bodies that define the requirement and monitor compliance to safety and environment specification which can impact the product and process. That is the regulatory requirement like ROHS requirement, like ELV requirements, like REACH compliance. Next is what is the FMEA terminology that we are using in FMEA. First is failure mode. What is failure mode? Failure mode is actually define the way or a manner in which product or process could fail to meet the design intent or process requirement. That is failure mode. The assumption is made that the failure mode could occur but may not necessarily occur. Means failure could occur but may not necessarily occur. We need to assume like that. Next is potential effect. Actually, potential effect of failure are defined, means potential effect of failure or failure mode are defined as the effect of the failure mode as perceived by the customer. How do customer perceive it? Means what are the effect on the customer? The effect or impact of a failure are described in terms what the customer might notice or experience. The customer that can be internal or external as well as individual. Next is potential cause. Potential cause means that is anticipated. Means potential cause of failure is defined as indication of how the failure could occur. Means how the failure could occur. Described in terms of something that can be corrected or can be controlled. Means how failure could occur, that is cause, and potential effect that perceived by the customer or individual, that is severity, and failure mode means that failure could occur but may not necessarily occur. Means failure means product or process could fail to meet their requirements. That is failure mode. Next is like controls. Means what controls we are applying to prevent or detect the cause of the failure or failure mode. Means first is cause of the failure, second is failure mode. Means cause of the failure, that is the prevention control, and failure mode, that is prevention and detection both control. Controls are applicable to design or manufacturing process. Controls focus on prevention will provide the greatest return. Means next terminology is identifying and assessing risk. Means one of the important steps in FMEA is to assessment of the risk. This is evaluated in three ways, that is severity, occurrence and detection. And severity is assessment level of the impact of failure on the customer or individual, and occurrence is how often the causes of failure may occur, and detection is assessment how well the product or process control their detect the cause of failure or failure mode. Means detection is both for cause of failure and failure mode, but cause of failure is on, that is on prevention. Prevention is a cause of failure. Next is recommended action and results. The intent of recommended action is reduce overall risk and likelihood that the failure mode will occur. Means the recommended action address reduction of severity, occurrence and detection ratings. Responsibility, timing, completion and recommended action should be recorded. Once actions are completed, result capture, updated rating for severity, occurrence and detection should be also recorded. And management responsibilities. Management owns the FMEA process. Means key responsible person is management. Management has the ultimate responsibility of selecting and applying resources and ensuring an effective risk management process, including timing. And what are the types of FMEA? Types of FMEA. First is the DFMEA that apply to a product is called design failure mode and effect analysis. Second is PFMEA that is applied to a process, that is process failure mode and effect analysis. Next is multidisciplinary approach. That approach actually developed and review of FMEA including action to reduce potential risk, that we need to multidisciplinary approach. Next is a special characteristic. A special characteristic that is fit, function, form, performance and government regulatory. The 5 requirements in a special characteristic that identifies process control documents including drawing, FMEA, control plan and operator instructions. Next is product design outputs, that is design FMEA and reliability results. Manufacturing process design output, that is manufacturing process FMEA. And next is control plan. Have a control plan for pre-launch production and take into the account that design FMEA and manufacturing process FMEA outputs. And control plan shall be reviewed and updated when any changes occurs affecting product manufacturing process, measurement, logistics, supply source or FMEA. Next is linkage between DFMEA and PFMEA. Actually a process FMEA, that is PFMEA, or a design FMEA, that is DFMEA, can result in the same potential product effect. In this case, the effect of design FMEA should be reflected in the effect and severity rating of the DFMEA and PFMEA also. Next is process FMEA. Potential means anticipated. It is an analytical technique that to assure that potential failure mode and their associated causes have been considered and addressed. Next is development of a PFMEA. PFMEA being developed by a list of what the process expected to do and what is expected not to do. Means the process intent is process should begin with a flowchart of a general process, and flowchart should identify the product process characteristic associated with each operation. And next is PFMEA should begin with the development of information to understand and manufacturing the assembly operation, being analyzed and define their requirements. Next is process flow diagram describe the flow of product throughout the process, means PFD and linkage to PFMEA, means process flow diagram and linkage of PFMEA, means first we need to prepare the PFD, then again PFMEA. Process flow diagram describe flow of the product throughout the process from incoming to outgoing. This should include each steps in manufacturing or assembly process as well as their related outputs, requirements, and inputs and input characteristic, output characteristic and sources of variation also. Means initial flow diagram is generally considered a high level process map. It needs more detailed analysis to identify the potential failure modes. Process flow diagram and linkage of PFMEA. In example, high level process map, that is a high level PFD, and detailed process flow diagram, that is two type of process that is mapping is given, high level process mapping and detailed process flow diagram. Process flow diagram and linkage to PFMEA. PFMEA should be considered with the information in the process flow diagram. Means the scope of process flow diagram should include all manufacturing operations from process of individual components to assemblies, including shipping, receiving, transportation of material, storage and conveyors, labeling, etc. A primary risk assessment using the process flow diagram may perform to identify which of these operations or individual steps can have an impact on the product manufacturing and assembly should be included in PFMEA. PFMEA continues by identifying the requirement for each process function. Requirement are output of each operation step and relate to the requirement of for the product. These requirements provide a descriptions of what should be achieved at the each operation steps. Requirement provide the team with a basis to identify potential failure points. In order to assure continuity, it is highly recommended that the same cross-functional team develop the PFD and PFMEA and control plan. It should be focused. Means same cross-functional team develop the PFD, PFMEA and control plan. Next is other tools and information sources, that is DFMEA drawings and design records, bill of process, and interrelationship metrics and internal external non-conformance, quality and reliability of the data. Next is research information. Team should review the historical information. The area to review should include lessons that have been learned from previous product or process design implementations, any information available, and establish best practices including items such as guideline, standard part identification, error proofing outputs, and the quality performance informations available from similar previous product or process design. Next is information can be useful input for determination of severity occurrence and reduction ratings. Next is what are the customer requirement or design specification, key product characteristic, machine process capability that we need to capture in PFD. Then we need to prepare our process PFMEA and process FMEA, and after the process control plan. On the base of the process FMEA output, we need to prepare the process control plan, and process control plan output is need to capture in operator job instructions, and operator job instructions need to confirming the product and confirming product produce, confirming product reduce variations and customer satisfaction. These are the linkage of the PFD, PFMEA control plan. Next is team member for the PFMEA. Means process engineers, manufacturing supervisor, operators, quality, safety, production engineer, customer and supplier all need to a team member of PFMEA. Next is PFMEA assumptions. Design is valid, all incoming product design specifications and all inputs and process are in line with the requirements. Failure can but will not necessarily occur. Design failure are not covered in PFMEA. They should have been part of design FMEA. Next is FMEA, that is process FMEA methodology. What are the methodology? First is FMEA number. FMEA number is alphanumeric string which is used to identify the FMEA document, also used for the documentation control. Next is item. Item enter the name or number of the system, subsystem or component processes being analyzed. Next is process responsibility, that enter the OEM or organization or departments or group who is process design responsible, who is key persons. Next is prepare by, that enter the name, telephone number and the company of the engineer responsible for preparing for the FMEA. Next is model year and program. Enter the intended model year program that will use and be affected by the design process being analyzed. Next is key date, that enter the initial FMEA due date, that we should not exceed the scheduled SOP date. Means before SOP we need to enter the key date. And in case of a supplier, the initial FMEA due date should not exceed the customer required production part approval process, means before PPAP. In case of supplier, we need to mention the initial FMEA due date, that is before PPAP submission date. FMEA date, they enter the date in the original FMEA that was compiled and latest revision date, that is latest revision date is FMEA date. Core team list the name of the responsible individual and department that have authority to identify and perform the task. It is recommended that each team member's name, department and telephone number address to be included in the distributions list. Next is process step. Enter the identification or the process step or operation being analyzed. Means and based on the numbering process and terminology, process numbering scheme, sequencing and terminology should be consistent and those used in the process flow diagram to ensure traceability. Means we need to focus on the all the terminology that mentioned in process flow diagram that incorporated in process step. Like repair and rework operations should also be included in that process step. Next is process function. Process function lists the process function that correspondent to each process step or operation being analyzed. Next, process function describe the purpose or intent of the operation. What are the purpose for this operation? Next is requirement. List the requirement for each process function, a process step or operation being analyzed. What are their requirement? Requirement are input to the process specification to meet design intent, other customer requirement. If there are multiple requirements with respect to given functions, each should be aligned on the form with the respective associated failure modes in order to facilitate the analysis. Next is potential failure mode. What is potential failure? Potential means anticipated. Potential failure mode defined as a manner in which process could potentially fail to meet the process requirement, including design intent. In preparing the FMEA, assumption that incoming parts material are correct and exceptions can be made by process team where historical data indicate the deficiency in incoming part quality. The team should assume that the basic design of the product is correct. The team should assume that basic design of product is correct. However, there are design issues which result in process concern. Those issues should be communicating to the design team for resolution. Means we need to assume that this is correct and also we need to identify there is a design issue or there is a process issue which result in process concern. List the potential failure modes for the particular operation in terms of the process requirement. Assume that the failure could occur but may not necessarily occur. Potential failure mode should be described in technical terms, not a symptoms noticed by the customer. Process FMEA that potential failure mode continues. That is means potential failure mode already explained that potential failure could occur but may not necessarily occur. Next is assumption is made that the failure could occur but may not necessarily occur. Means consequently the use of the word potential. Verification of completeness of the potential failure mode can be made through a review of past things that gone wrong or concerns. Next is reject or scrap reports. Group brainstorming source of these should also be included in comparison of similar processes. Next is potential failure mode. Their process steps, process functions, requirements and potential failure mode. This is an example. Potential failure mode example. Like operation number is 20 and step number is 20. Their function is attach seat cushion to track using by the torque gun. Requirement is 4 screw and specified screw. Assembly sequences: first screw is right front hole, screw fully seated and screw torch to be dynamic torch specification. Now their potential failure mode. 4 screws, fewer than 4 screws, with less screws available there. Specified screws, wrong screws used. Failure mode is assembly sequences that screw placed in any other hole and screw fully seated, screw not fully seated. Screw torch to dynamic torque specification, that screw torque too high, screw torque that is too low, means screw torque is too low and screw torque is too high. That two failure mode is generated. Next is potential effect of failure. That failure mode means potential effect of failure mode are defined in the effect of the failure mode as perceived by the customer. Effect of failure mode should be described in terms of what the customer might notice or experience, and remembering that customer may be internal or external as already explained. The product effect in PFMEA should be considered in those that the corresponding TFMEA, and if the failure mode could impact safety or cause non-compliances should regulatory, it should be clear identify the PFMEA. For the end user, the effect should be stated in terms of product or safety performance. If the customer is next operation or subsequent operations location, the effect should be stated in terms of process operation performance. Next is in order to determine the potential effect, the following questions should be asked. Means for potential effect of failure mode, we need to ask the following question: does the potential failure mode physically prevent downstream processes or cause potential harm to equipment or operation? And next is the include or inability or assemble or join a meeting components at any subsequent customer facility. If so, then assess the manufacturing impacts. Now, unable to assemble at operation X, unable to attach the customer facility, unable to connect the customer facility, cannot bore at operation X. These are some potential effects. Damage equipment at operations, endanger operator as customer facility. Next is what is the impacts on the end user. The first is the does the potential failure mode physically prevent downstream processing or cause potential harm the equipment or operation. That is the first. And second effect is what are the potential impacts on the end user. Independent of any control planned or implemented, including error or mistake proofing, consider what the end user would notice or experience. This information may be available within the DFMEA. Once determined, go to question 3. That example could include noise. End user can feel noise, high effort, unpleasant odor, and water leakage, rough idle, unable to adjust, difficult to control, poor appearance. And next is what would happen if an effect was detected prior to reaching the end user. Means before reaching the end user, if the defect is detected, then the potential effect at the current or receiving location also need to be considered. Means like line shutdown, like stop shipment, like yard hold, like 100% product to be scrapped, like decreased line speed, added manpower to maintain requirement line rate. Means we need to think like that. Next is example of potential failure mode. This is the 4 screw requirements, that fewer than the 4 screw, that is the that is failure mode. Now next is their effect on end user: lost seat, cushion and noise at manufacturing assembly line, stop shipment, and additional short and rework due to affecting portion. Next is that requirement is specified screw, but failure mode is wrong screw used, that in manufacturing and assembly unable to install a screw in the station. Next is screw not fully seated. End user loose seat, cushion and noise can be happen. manufacturing and assembly, there is a sort of rework due to affect portions. And next is failure mode is, that is requirement is screw charge too high, that can cause the end user lose seat cushion due to subsequent fracture of the screw or noise. Next is at manufacturing and assembly line, short and rework due to affect portions. And next is screw torque too low, that end user cause loose seat cushions due to high gradual losing of the screw and noise. Next is at manufacturing and assembly line, short and rework due to affect portions. Next is severity. Failure mode, their effect at end user, their effect as assembly or manufacturing lines. Now severity. Severity is the rank associated with the most serious effect of a given failure mode. Severity is relative ranking within the scope of the individual FMEA. Suggested evaluation criteria, the team should agree on the evaluation criteria and ranking system that is considered even if modified for individual process analysis. Severity should be estimated using severity table as given in AIG guideline. It is not recommended to modify criteria for ranking value of 9 and 10. Failure modes with a ranking of severity 1 should not be analyzed further. Means we cannot analyze further. That should avoid. And next step is classifications. FMEA, PFMEA terminology is classification. This column may be used to classify any special product or process characteristic that is critical, key, major or minor or significant for component, subsystem, system that may be required additional process control. This column may also be used to highlight high priority failure mode for engineering assignment, where a special characteristic is identified with a severity of 9 or 10 in PFMEA. The design responsible engineer should be noticed, since this may affect the engineering documents. Customers should requirement may identify a special product or process characteristic, symbol and their uses. Next is potential causes, mechanism of a failure. Potential cause or mechanism of a failure. What are the potential cause? What are their mechanism of the failure? Potential cause of failure is defined as indication of how failure could occur, and is described in terms of something that can be corrected or can be controlled. Potential cause of failure may be indication of design or process weakness, the consequences of which the failure mode occur. To the extent possible, identify the document if potential cause of for each failure mode. The cause should be detailed in consistently and completely as possible. Separating the causes will resulting in focus analysis for each and may yield different measurement, controls and action plan. There may be one or more causes that can result in failure mode being analyzed. This result in multiple line for each cause in the table or form. In preparing the PFMEA, the team should assume that the incoming parts materials are correct. Exception can be made at the team's discretion where the historical data indicate deficiency in the incoming part quality. Next is occurrence. What are the occurrence table? Actually, occurrence is likelihood that a specific cause of failure will occur. Means likelihood of occurrence. Ranking number has relative meaning that, rather than absolute value. That there is a ranking table of occurrence that given in AIAG manual, and we can download on net also. Estimated the likelihood of the occurrence of the potential cause of failure 1 to 10 scale. A consistent occurring ranking table system should be used to ensure continuity. The occurrence ranking number is a relative ranking within the scope of the FMEA and may not reflect the actual likelihood of the incident per item vehicle is used to indicate the number of failures that are anticipated during the process executions. If statistically data is available from a similar process, the data should be used to determine the occurrence ranking. In other cases, subjective assessment can be made by using the word descriptions in the left hand column of the table. Along with the input from the appropriate process knowledge source to be estimated the ranking. Means occurrence rating, we need to focus on the data. Next is suggested evaluation criteria. The team should agree on evaluation criteria and ranking system. Apply them consistently even if modified for the individual process analysis. Occurrence should be estimated using 1 to 10 scale based upon the table or AIAG guideline. Current process control. Next is current process control are descriptions of a controls that can either prevent to the extent possible the cause of failure from occurring or detect the failure mode or cause of a failure it occurs. Means current process control is both controls on both either prevent the extent possible the cause of failure or occurring or detecting the failure mode also. Cause of failure and failure mode also. There are two types of process control. Prevention. Prevention is on eliminating or prevent the cause of failure or the failure mode from the occurring or reducing its rate of occurrence. That is prevention. Reduction is the cause of failure or failure mode leading to the development of associated corrective action or countermeasures. Means prevention is focus on cause of failure and reduction is focus on the failure mode. Next is process FMEA. In this FMEA actually prevention and reduction, that prevention is eliminating or preventing the cause of failure and failure mode from occurring, and reduction is identify detecting the cause of failure or failure mode. That both are focused on failure, cause of failure and failure mode also. Next is process FMEA. That preferred approach is to use prevention control. Means if possible the initial occurrence ranking will affect by the prevention control provided they are integrated as part of the process. The initial detection ranking will be based on the process control that either detect the cause of failure or detect the failure mode. First is failure, cause of failure, then after failure mode. And because the statistical charting method, statistical process control typically use sampling to assess the process stability and detect out of control conditions, they should not be considered when evaluating the effectiveness of a specific detection control. SPC may however be considered as a prevention control for a specific cause. Be considered as prevention control for a specific cause where trends are identifiable in the advance of an actual non-conformance being produced, such a tool bear. The example PFMEA form in this manual has two separate columns of prevention control and detection control to assist the team in clearly. They distinguish between those two types of control. This allows a quick visual determination that both types of process control have been considered. If one column for a process control form is used, then the following preferred should be used. For prevention control, place a P before and after each prevention control listed. For detection control, we should place a letter D. That is the example of process of FMEA, that is requirement, failure mode and their causes, and prevention control and detection control. Like First is screw not fully seated, that failure mode. That causes is nut runner not held perpendicularly to work surface by the operation. Their prevention control is operator trainings. Next is screw. Direction control is angle sensor included in the nut runner to detect the cross threadings, not allowing the part to remove from the fixture until the value is satisfied. Screw task is dynamic to dynamic torque specification. Their failure mode is screw torque too high, that causes screw torque set too high by the non-setup personnel. Next, prevention control is that password protected control panel we need to provide it, and their detection control is torque validation box included in setup procedure to validate setting prior to running. Next is the torque setting, that causes setting torque too high by setup personnel. That training of the prevention control is training of setup personnel. And next is setting added to setup instructions, that added in WI is training and password protection. These are the prevention control. Next is detections. Detection is rank associated with the best detection control listed in the detection control poll. Detection is a relative ranking within the scope of individual PFMEA. In order to achieve a low ranking, generally the planned detection control has been improved. When more than one control is identified, it is recommended that the detection ranking of each control be included as part of the descriptions of the control. Record of the lowest ranking value in detection control. Assume the failure has occurred and then assess the compatibility of all. Current process control to prevent shipment of the part having this failure mode do not automatically pressure that the assess the ability of process control to detect low frequency failure modes or prevent them is going further in the process. Random quality checks are unlikely to detect the existence of an isolated problem should not influence the detection ranking. Next is suggested evaluation criteria. The team should agree on evaluation criteria and ranking system, apply them consistently. Even if modified the individual product analysis, detection should be estimated using by the table or AIG guideline. The ranking value of 1 is reserved for the failure prevention through proven process design solutions. And detection determining the action priority. Once the team has completed the initial identification of failure mode and effect, cause and control, including ranking for severity, occurrence and detection, they must decide if further effort are needed to reduce the risk due to the inherent limitations on the resources, time, technology and other factors. They must choose how to best prioritize these efforts. The initial focus of the team should be oriented towards failure mode with a highest severity ranking. When the severity is 9 or 10, it is important that the team ensure that the risk is addressed through existing design control or recommended actions. For failure mode with severity of 8 or below of it, the team should consider the causes having the highest occurrence or detection ranking. It is team's responsibility to look at the information, decide upon an approach and determine how the best priorities their risk reduce effort which best severe the organization and as well as customer. Risk evaluation and risk priority numbers, RPNs. Once approval to assist in action prioritization has been to use the risk priority number. Risk priority number is severity multiplication of severity, occurrence and detection, that is SOT. Within the scope of the individual FMEA, this value can be ranged between 1 to 1000. The use of an RPN threshold is not a recommended practice for determining need for actions. Applying threshold assumptions RPN are measure of relative risk, which they often are not, and that continuous improve is not required, which it is. For example, if customer applied an arbitrary threshold of the 100 to the following, the supplier be required to take action on the characteristic that given B with the RPN of 112. That item A severity is 9, occurrence is 2 and reduction is 5. Their RPN is 90. And in item B severity is 7, occurrence is 4 and reduction is 4, then RPN is 112. Now the customer is applied an arbitrary threshold to 100 of, means we should take the action on 100, but the supplier would require to take action on the characteristic B because of their RPN is more than 100. But in technically option A is correct, means first we need to focus on severity, then occurrence, and again after that reduction. In this example, the RPN is highest for characteristic B than the characteristic E. However, the priority should be to work on A with the higher severity of 9, although RPN is 90, which is lower and below the threshold. Another concern with the using the threshold approach is to there is no specific RPN value that required mandatory actions. Unfortunately, stabilizing such threshold may promote the wrong behavior, causing team members to spend time trying to justify a lower occurrence or reduction ranking value to reduce the RPN. This type of behavior avoid addressing the real problem that underlines the cause of failure mode and merely keep the RPN below the threshold. It is important to recognize that while determining the acceptable risk at particular program milestone vehicle launch is desirable, it should be based on the analysis of severity, occurrence and reduction, not through the application of RPN threshold. Means we should not focus on RPN threshold, we should focus on severity, occurrence and reductions throughout the applications of RPN. Means use of the RPN index in the discussion of the team can be useful tool. The limitations of the use of RPN need to understood. However, the use of RPN threshold to determine the action priority is not recommended. Next is recommended action. In general prevention action, reducing the occurrence are preferable to determination reduction actions. Means in general prevention action, reducing the occurrence are preferable to reduction action. An example of this is used to process design error proofing rather than random quality checks or associated instructions. Means we should focus on prevention action. The intent of any recommended action is to reduce ranking in the following order. First is severity, then occurrence and after that reduction. Example approaches to reduce, these are the explained below. To reduce severity ranking, only a design or process revision can be being about a reduction in severity ranking. A product or process design change in of itself does not imply that the severity will be reduced. Any process or product design change should be reviewed by the team to determine the effect on the product, process, function and process. For maximum effectiveness and efficiency of this approach, change to the product and process design should be implemented earlier in the development process. For example, process technology need to consider very early in the process development if severity is to reduce. Next is to reduce occurrence rating. To reduce occurrence rating, process design revision may be required. A reduction in the occurrence ranking can be effected by the removing or controlling one or more of the causes of the failure mode through a product or process design revision. Studies to understand the source of variation of process using statistical methods may be implemented. These studies may result in the actions that reduce occurrence. Further, the knowledge gain may assist in the identification of suitable control, including ongoing feedback of the information to appropriate operations for continuous improvement and problem prevention. Next is to reduce the detection rating, that is D. The preferred method is used to error or mistake grouping. If redesign of the detections methodology may result in reduction of the detection ranking. In some cases, a design change to process step may require to increase the likelihood of the detection, that is reduce the detection ranking. Generally, improving detection control require the knowledge and understanding of the dominant cause of process variation and any special causes. Increasing the frequency of the inspection is usually not effective actions and should only be used as temporary measure to collect additional information on the process so that the permanent prevention or corrective action can be implemented. If the assessment lead to no recommended action for a specific failure or cause or control combinations, indicate this by entering none in the column. If it may be useful to also include a rationale if none is entered in, especially in the cause of high severity. For process action, the evaluation may included but not limited to result of process DOE or other testing, modification process PFD, flow plan, work instruction, preventive maintenance plan, review of equipment and machinery specification, new or modified sensing detection devices. Next is the example that is process step function, their requirement, failure mode, their causes, prevention control, detection control, and now is recommended action. Now first example is operation number 20, that is seat cushion to attach using a torque gun, that select 4 screws. For selecting 4 screws, requirement is 4 screws, failure mode is fewer than 4 screws, causes is too few screws inadvertently installed, prevention control is visual aids and illustrating correct quantity, operator training is given, detection control is visual inspection in station, and recommended action is in station torque monitoring line lockout if fewer than the 4, means there is a detection control, that is recommended action. Next is specified screws, that requirement is now wrong screw used, that is the failure mode, and cause is similar screws available at the stations. Prevention control, visual aid illustrating correct screws, the visual aid is given there to use the correct screw. Next is operator training is given. Detection control, visual inspection in station, and recommended action in station torque angle monitoring line lockout if angle not means. Next is error proofing by design, use one type of screw for a station or product. Next is next process terminology is responsibility for the recommended actions. What are the enter the individual responsible for the recommended action and target completion date. Action taken, after the action taken actions have been implemented, enter the brief descriptions of the actual action and effective days and action result. This section identify the result of any completed actions and their effect on SOD ranking, severity occurrence and direction ranking, and RPM. After the preventive and corrective actions had been completed, determine and record the resulting severity, occurrence, direction, ranking, record the RPM. All revised rankings should be reviewed. Actions alone do not guarantee that the problem was solved. Thus, the appropriate analysis or test should be completed as verification. If further action is considered necessary, repeat the analysis. The focus should always be on continuous improvements. Next is maintaining PFMEA. Now the FMEA is a live document, that is living document, should be reviewed, and whenever there is a product or process design changes or updation is required. Another element of ongoing maintenance of FMEA should include a periodic review, that a specific focus should be given to occurrence and direction ranking. There is a particular importance where there have been product or process change, improvement in the process control, additional in case where there is either field issues or production issues such as descriptions have occurred, and ranking should be revised accordingly. If a few project application is functionally similar to the existing product and process to be used in similar, a single PFMEA may be used with customer concurrence. If there are differences, the team should identify and focus on effect of these differences. Next is linkage, PFMEA linkage, that is linkage is DFMEA process flow diagram and PFMEA and process control plans, that are linkage of DFMEA, PFMEA control. Critical characteristic that which are affect customer safety and could result in non-compliance to regulatory, that is critical characteristic, that is non-compliance to regulatory and customer safety, affect the customer safety. Significant characteristic, that those are which affect fit, form and function, that are significant. A special characteristic that affect both significant characteristic and critical characteristic, that are special characteristic. Classification of risk, that is high, moderate and low risk, means that is a relationship between severity of outcome and possibility of occurrence. Failure mode and effect analysis, that is an example for a high risk and low risk, means factors that have high and critical, that is severity is high and occurrence is high, that is high risk, and that severity is low, that is low risk, occurrence is also low, direction is also low, that is in low risk. Next is high risk, means risk profile. For high risk which are not suitable, risk reduction measures have to be taken as high priority. And alternative risk assessment, that is alternative risk assessment method are suggested below, that is RPN rating. First is RPN, next is SOD rating, that is like S is example first, S is 7, rating is 7, occurrence is 7 and direction is 3. Their RPN is 147, but SOD, that is severity, occurrence and direction, that is 773, and SD is 73, and some are using the SO table, that is severity and occurrence table. The SOD rating can be expressed as the above have higher degree of prioritization for the potential failure modes with higher severity. When using the alternate risk assessment method, that result of rating must be get reflected in all control defined on control plans. This is the one example of the severity, occurrence and direction, their results and their actions. Now first is severity 1, occurrence is 1 and direction is 1. Ideal situation, that is action not required. And now severity is 1 and occurrence is 1, direction is 10. Process capability is good, poor direction is, that address direction control. Now severity is 10, occurrence is 1 and direction is also 1. Failure does not reach user, means process is capable, direction is good, but review their product design. Now severity is 10, occurrence is 1 and direction is 10. Then failure reaches user, increases in customer and non-conformance, high risk, that address direction control first, then review the product design, both. Now severity is 1 and occurrence is 10 and direction is also 1. Frequent failure, because deduction costly and increase in internal non-conformance because occurrence is more, plan process improvement and poka-yoka because occurrence was more. Now next is severity is 1, occurrence and deduction is 10. Frequent failure as reaches users increases in customer end non-conformance. Improve deduction first, then process improvement poka-yoka. Now severity and occurrence is 10 and reduction is 1. Frequent failure with major impact, increase in internal non-conformance, high risk because severity and occurrence both are high. Now immediate process improvement and poka-yoka review and product design review also required. Next is all the three are in 10, rating 10. Big trouble, frequent customer complaints, high risk customer dissatisfaction, loss of business can occur. This all hands on deck break means management to act, means need to management actions. Next is review. When PFMEA completed, never, and FMEA is never completed unless the process is removed from the production line, and linkage between PFMEA and control plan. In addition to listed of the recommended action, there are subsequent follow-up. Result of PFMEA activity, a control plan should be developed. Some organization may elect not to identify the related product and process characteristic in PFMEA. In this situation, the product characteristic portion of the control plan may be derived from the requirement, portion of the process function requirement, column of the process characteristic portion may be derived from the potential causes of failure mode. Next is when the team develop the control plan, they need to assure that the PFMEA current controls are considered with the control plan, control methods specified in control plan. Means current control need to consider along with the control plans. Thank you very much. Please like and subscribe the my YouTube channels.